So what we are most interested in with the series is where the series converges. So we're going to look at a geometric series first. So the question is, for what values of x does this geometric series converge? One way to think about it is, what numbers could I plug in for x here, and then if I add up all the terms infinitely, are you going to get to a sum? Okay, so first of all, you need to identify your r value if it's a geometric. So your r is x minus 3. And we learned that a geometric series only converges if the absolute value of r is less than 1. I can go ahead and solve this inequality. So this is called your interval of convergence. So you can write it as an inequality, you can write it in interval notation. It's saying that if you plug in any number between 2 and 4 in for x here, if you add up those terms infinitely, you will get to a sum. And the sum would be a over 1 minus r. Now it is important to note that you do have parentheses here, not brackets. There's no equal sign, because remember, for a geometric, if r is equal to 1, it actually does diverge. So this is your interval. Now we're going to talk about another word called your radius of convergence, and I'm just going to use a capital R for it. Your radius of convergence is actually just a number. It's basically saying it's this number right here. Whatever the center of your series is, the center is 3 here. How many units are you going in either direction? I'm going 1 in either direction. Or you can look at it from here. The center is 3. I'm going to the right 1, to the left 1. So your radius of convergence is 1. Okay, let's look at the next one. This is also a geometric series. You can rewrite this if you want. This is really the same as 3 to the n times 3 to the first on the bottom. So the 3 to the first is a constant multiple you can pull out. So your r is really x over 3. Again, we know that a geometric series converges if the absolute value of r is less than 1. If I solve this, I get to here. So this is my interval of convergence right here. My radius of convergence, my center is 0. I'm going 3 either direction, so my radius would be 3. Now, for other series that are not geometric, we don't have an r value we can pick out. The only way to find radius and interval of convergence is to use the ratio test. So for these problems here, all we're going to find right now is the radius of convergence for right now. So this is not geometric series, because even though the x and the n and the 3 are raised to the nth power, you have this extra n here. So I'm going to go ahead and use the ratio test. So set up your ratio test. The n plus first term divided by the nth term, so just multiply by the reciprocal. Okay, again, let's simplify a couple things. Notice you'll end up with just an x to the first on the top. Oops, I forgot a plus 1 here. You'll end up with a 3 on the bottom, and you still have this n and this n plus 1. Now, when you take the limit, remember we're plugging infinity for n, degree is the same, ratio of the lead coefficient is 1, so your limit leaves you with x over 3. So the ratio test, remember, says the series will converge if that limit is less than 1. So if I solve this, this is what you get. Your center is 0, and your radius of convergence is 3. For right now, we're not going to talk about the interval of convergence using the ratio test yet.